finish the unit commitment. So we will give you an example, very simple example, a system with 3 units only, and we have only 3 level of loads, or we need to prepare the schedule for 3 periods only. So it is very simple, and we will see how much computation is involved in this very simple example. So this example, you have here 3 units, A, B, C, and these are the limits of each unit, B minimum, B maximum, so you have it here. And you have also other constraints and unit commitment, minimum startup and the minimum shutdown. So if you start up a unit, you have to keep it on for 3 periods. This is for unit A. Unit B, you have to keep it on. If you switch it on, then you have to keep it on for 2 hours. Unit C, if you switch it on, if the status of that unit changes from 0 to 1, so you have to keep it on for 1 hour. Okay, here for 2 hours, here for 3 hours. The minimum shutdown time also 3 hours for unit A. So if its status changes from 1 to 0, so you have to keep it 0 for 3 hours. This is the minimum shutdown time. So this 1 hour and this also 1 hour. No load cost is 0. There is no load cost. There is no cost if the machine is not loaded. The marginal cost, the dollar per megawatt hour, lambda, the incremental cost for unit 1 is $10 per megawatt hour, $12 per megawatt hour, $20 per megawatt hour. And the startup cost is $1,000 for unit A. If you change the status of unit A from 0 to 1, you switch it on, then this is the cost involved here. You have to pay $1,000 for startup. For this one is $600, and this one for $100 if you switch it on. If you start it up, then you have to pay $100 here. The initial status of these units is 100. You have here 1, status 0, status 0. So you have the solution is 100. You start with this one. So starting with this solution, let us schedule these units for a load level of 150 megawatt, and the second load level is 300 megawatt. The third load level is 200 megawatt. So you have 3 periods. For each period, you have a certain load you need to cover. And starting from this solution 100, so what would be the solution here? What would be the solution here? What would be the solution here? The status. Okay, this is of course in order to minimize the cost. We need at the end to minimize the cost. And which combination will give you the minimum cost over the 3 periods. We are not solving now for a certain period. We are solving for the 3 periods together. The reserve requirements are not considered. Don't consider the spinning reserve requirements. If you want to consider them and you are given the spinning reserve is 10% of the load, so this load will not be considered as 150, but it will be considered 150 times 1.1 يعني 1.65 sorry 165 megawatt. Okay, if you consider the spinning reserve as 10%. And here it's mentioned clearly and the reserve requirement is not considered. So you work on these levels 150, 200, 300 and 200 here. Okay. Type. Okay. So can we start investigating what are the possible combinations at this load level, and then what is the possible combination at this load level? What are the possible combinations at this load level? And keep in your mind also the constraints that we set here, and the minimum minimum startup, and the minimum shutdown, and all these constraints must be observed. Okay, so if you have 3 units, how many combinations do we have in general?
8. 2 to the power 3.
2 to the power 3. For 3 periods again, and we have here 3 periods or 3 load levels or 3 hours. So 2 to the power 2 to the power 3 to the power 3 and 2 to the power 9. And we can have like 512 combination. So in this very simple problem, you need to investigate 512 combination. Okay. So, but of course, if you observe these limits in load levels and startup and minimum shutdown time and so on, you can eliminate a lot of these combinations and you end up with few combinations to be investigated, as you will see here. Okay, so here we have all these combinations. We have 8 combinations here. Unit A, 1s and 0s, B, 1100, 1100, and C, 100. So these are the 8 combinations that we have. And for each combination, you will see the minimum and the maximum. And for this one, the minimum and maximum is 0. For this one, we have only unit number 3. So the minimum maximum are given there. So 10 and 50. And then for unit 2 only, for unit 2 and 3, so 10 plus 15, 50 equal to 60. And this becomes the maximum is 150. This is the machine number 1 only. So these are the limits of machine number 1, 1 and 3, 1 and 2, 1, 2, 3. So you can easily construct B minimum and B maximum for each combination that we have. This is, I think, this is straightforward, right? Okay, so now we have 3 load levels, 150, 300, and 200. So for balance, one of the constraints, as we mentioned earlier, in the summation of BG, it's equal to demand. يعني neglecting the reserve. So summation of BG must equal to the demand, equal to the load. So in this case, if you have 150, which combinations would be visible? For example, this combination, if we run all the units 111, can we cover this load or not?
No, it's below because
this load is below the combination, this combination. So this combination is unfeasible for 150 megawatt load. This combination is unfeasible. for at that period. For 110, the minimum is 200, load is 150, so generation is higher than the minimum generation is higher than the load. So this also is unfeasible combination. The minimum here is 160. It's still greater than, so this combination is unfeasible. This one?
Feasible.
Yes.
This one?
Feasible.
This one?
No.
The maximum is 100 and the load is 150. So this combination is unfeasible. Okay, this combination also is unfeasible, and definitely this combination is unfeasible. So in this case, for 150, for period 1, you have 2 feasible solutions or combination, and the others are unfeasible. Okay. This is for 150. Let us check for 300 now. For 300, this one
Feasible.
and this one
Feasible also.
and this
Feasible.
Feasible.
this one.
No.
Not feasible.
All the remaining are unfeasible solutions. And maximum is below the load. So we have also here in this period, we have 3 combination are feasible and the remaining is unfeasible. Okay, so for the third period, 200, you have this
Unfeasible.
and this is
No,
200.
we can't.
And this is 200, so it is higher. So this is unfeasible. This is feasible. This is feasible. And this is also feasible. And the remaining are unfeasible solutions. So for the third period, we have these feasible combination, and the remaining are unfeasible combinations. So based on these constraints only, based on these constraints, you can see how many combinations we eliminate. Now we end up with how many combinations? If this is the case, 2 times 3 times 3, right?
Just 18.
Is it clear? So after eliminating these combinations, we end up with 2 times 3 times 3. So this means you have 18 combination. These are the feasible combination according to this constraint only. Is it clear? So you can imagine now how many or the percentage of the solutions that be eliminated due to these constraints. Okay, so we have only 18 out of 510, 512. So we end up with only 18. Based on this, based on this based on this constraints only. And we didn't, still we have to investigate the other constraints, minimum shutdown time, or minimum start shutdown time, or start up time. So, but for this constraints only, we eliminate so many combinations, and we end up with 18 combination only. And this 18 combination, when we consider the other constraints, we will eliminate some of those combinations due to constraint violation. Do you have any question? And I heard someone need to ask. If you have any question, please.
Yes, I was gonna say we are eliminating 96% of the possible solution.
دي أول طلعة يا علي. يعني we eliminate 96%. يعني دي أول إيه؟ اول حاجه كده على طول يعني بس one constraints we can eliminate so many combinations and we will check further these 18 combinations 2 times 3 times 3. So we will see here what are the combination. Maybe for this one, for example, you have 1 0 0. So you have here unit number 1 is A is on, and if it is on, if you go back to the constraints, if A is on, you have to keep it on for 3 times, 3 periods. And if you switch it off, you have to keep it off for 3 periods. And also for B. So minimum start, if you switch it on, you have to keep it on for 2 periods. So some of these combinations will be unfeasible, even if we go. So some of these combinations will be unfeasible due to such constraints. And for example, for this one, you have here 0 1 1. يعني اليونت 1 is switched, اليونت 1 is switched off, right? هو احنا we are here initially, the initial solution or initial combination was 1 0 0. This is the initial combination. So if this becomes a 0, that means you switch off unit A. يعني if you compare this combination with this combination, okay? So if you here you switch this off, and maybe this will violate the minimum startup time. So maybe this combination in a certain period is not feasible, and so on. So okay. So in conclusion, according to the generation, balance with the load here, we eliminate so many combination, and when we end up with this one, and then we will further investigate the other combination. طيب, okay, so we have this only. خلاص احنا we eliminate the others and we keep only this. So if you are here, طبعا initially you are here, and you may continue, you may go to this switch, go to this combination. From this combination, either you go to this one, or to this one, or to this one. You have 3 possibilities here. You can switch the combination to this, or from this combination you can go to these combinations as well. And if you are here in the second period, you can go, theoretically, you can go to this, any one of these combination, and also for this one, and also for this one. But of course, some of these combinations will be unfeasible due to the other constraints, due to the minimum startup time and the minimum shutdown time. لأنك أنت here you, for this one, what is the combination here is 1 1 1 0 0. What is the combination here is 1 1 1, right? What is the combination here is 1 1 0. Combination here is 1 0 1, and so on. Here you have this one as 1 1 0. This is the combination, and this is 1 0 1, and this is 1 0 0. Okay. For example, let me ask you one question. If you know that machine number 2, for example, here this is the constraint on machine number 2 or unit B, the minimum startup time is 2. The minimum startup time is 2. If you switch it on, you have to keep it on for 2 hours or 2 periods. So let us go back to this combination. And check here. If you are here, 100, and you go to this one, so this becomes what? 110. Yani you switch the unit B, switch it on here. Am I right?
Yes.
Are you following?
Yes.
Yes, yes.
Right. Now, if you move to this one, to that one, what does it mean? And this unit is switched off here, right?
Yes.
Yani you run it only for 1 hour, which violates the constraints. And this length or this combination is not feasible. Why? Then here, if we move from this combination to this combination, we switch unit B on. And then in the next period, we switch it off, which violates the limit of the minimum startup time. Minimum startup time should be two periods. Did you get the point? This is very important point. You have to understand it. If you have any question, please ask. And thank
Yes,
you.
doctor.
Yes, please.
Actually, I didn't understand how do we get this number 100.
This is the combination here. أنا بتكلم عن الكومبينيشن دي اللي هي 100 اللي هي دي. And this represents the combination of 100. This one also represents the combination of 100, and this is 100, right?
Okay, I see.
But this is of course unfeasible for now. We are not. Oh, this is feasible here, and this is the. Okay, so this combination comes from here. Yeah. This is 100, and this one 101, which is 101, and this is 111. You have here 111. So this combination is 111. Okay, is it clear? Okay.
Yes, thank you.
Okay, so with the load generation balance, we eliminate so many combinations, and we will look at the remaining combinations, and we will check the constraints: minimum startup time, minimum shutdown time. So we have to investigate this. We need also to eliminate some of these combinations. For example, if you are here, this is the initial status or state. The initial state is 100. If you go to this one, this is feasible solution or feasible combination. But if you go to this one is 011. What does it mean? Yani this movement, what does it mean?
We can't start.
Switch
again.
the first off and the second and third on.
Okay. Right. Can we switch this one off?
We need to know further when the machine did started.
Assume that this is the initial state. And this is the initial state. Start from here. We have this is 100. This we start from here. So can you switch it off directly?
No.
Or
No.
you have to keep it on
3 hours.
You have to keep it on.
You have to keep it on for 3 hours. You have to keep unit A on for 3 hours. So if this is the case, if this combination or movement sync is not feasible. It's not feasible to turn off unit A immediately after one period. So this is unfeasible movement. So if this is the initial state, Of course, we can move this way or this way. We have only two feasible combination here. We can move from this way or from this to this combination. And if you are here, you can go to the three combination feasible here. And if you are here, you can go to any one of those, but you have to observe the constraints of minimum startup and the minimum shutdown time. Is it clear? I
Yes,
hope
clear.
this point is clear.
Clear,
We
Doctor.
will build on this point later. So, okay, so this is the remaining combination. And let us start, see how can we eliminate the others according to the minimum startup time. مثلا for unit A, minimum uptime equal to 3. So which combination is valid according to this constraint?
First one.
First one. And this one will be unfeasible. Right? Is it clear?
Yes. Yes.
And if you move to this unfeasible, معناها انه this state does not exist or doesn't exist. معناها ان 3 links here also will be broken. Until you are not here, you cannot go to this point. So these combinations also will be broken. Is it clear?
Yeah, clear.
So based on this simple constraint, again we eliminate. You can see how many combinations you have here now. 1. You have 1 times 3 times 3. So you have 9 combination now needs to be investigated. And you have to check them against other constraints. Again, it is not only that constraints. That constraint only with the minimum startup time for unit A, we eliminate 9 combinations. Okay, these are 8 combinations, we eliminate 9, so we have only 9 feasible combinations now. And let us go and investigate about the other minimum startup time and the minimum shutdown time. So you have to, that's this. Okay, so in this case, due to the minimum startup time, you have 3 hours for unit A. And if you go to this one, that means when you switch this off, and this is unfeasible solution. So you eliminate all these combinations. So you start with this one. You have this combination, and you have either these combinations here and this combination here. Okay. طيب, can we investigate the others? لأنه you have here, we have this 1 0 0. This is a combination 1 0 0, and this one is 1 1 1.
Yes.
Right? And the other is 1 1 0. And this one is 1 0 1. Am I right?
Yes.
Yes.
Okay. So 1 1 1, 1 1 0, and 1 0 1. So these are the combination. What about those one? This is the 1 1 0. And this 1 0 1. And this one is 1
0 0.
0 0. Okay, great. Right, okay. So let us see these, these links. Does these links, this one قلنا انه violate the constraint of minimum startup time for this, or start on or on time. Okay. So this link will be broken, and accordingly these 3 links will be broken. So this is okay. Now, can we move from this one to any of those combination without violating any constraints of those ones?
Yes.
Okay, so الunit B, if it is on, you can keep it on for one period, and if it is off, you have to keep it off for 2 periods. Is it clear?
Isn't it opposite, Doctor?
This is the, let us go back to the initial problem. This is the minimum uptime. Minimum up time is 2. The minimum shutdown time is 1. So I think there it is opposite. Yani 1, 2. It was 1, 2. But this is the minimum down, and this is the minimum up. Okay. So it is the same here. But probably this is the minimum down 1 and the minimum up 2. Is it clear?
Yes.
Okay. Yes.
Okay. Right. Let us go and investigate this link. This link gives us machine number 1, unit 1 will be stay on. Machine number 2 or unit B will be turned on. Do we have any violation now? If we turn on machine number 2?
No.
I think
It's okay. It's okay. We can turn it on. For machine number 3, we turn it on. There is no problem, no violation. So this combination is okay, and we will consider it. And for this one, again, we switch on machine number 2, which is okay. And for machine number 3 is off, stay off. خلي بالك لما نقول minimum يعني minimum shutdown time يعني you cannot turn it on before this number. انما you can keep it off for longer. مش كده ولا ايه؟ يعني واحد يقول ان هنا ادي 1 دي 100 and you have machine number 3 here is 0, machine number 3 here is 0, machine number 3 here is 0. It's okay. يعني this is the minimum, but you can exceed, of course, this. You can keep it off for longer time. So this is also feasible link. For this one, you have 1 stay on, machine number 2 stay off, no problem. Machine number 3, you turn it on. Again, there is no violation according to this link. Am I right? Are you following, ya Shabab?
Yes.
Yes.
If you have any
Yes, clear.
questions.
Yes.
Okay, great. Right, now let us go to these links. Let us go to this period. From period 2 to period 3. This is 110. Okay. Here, you here for this one. What about this link?
Okay.
It's fine.
Fine.
طيب, what about this link? Second one, this one.
No, we can't.
No.
Why?
Because we
The
are
unit
for
B
2 hours.
2 period.
If you turn on machine number 2, you have to keep it on for 2 hours. So here it was 0, and then you turn it on, and then you turn it off. This violates the limits. This violates the constraints here. And this shouldn't be the case. Yani even this link should be broken. Shouldn't be investigated. لأنه unfeasible link, unfeasible movement, unfeasible solution to have it 111 and then 101. Okay? So, and then you can go and proceed for the other combination according to these constraints. Okay, so this is the case here. This is the case here. For this one also will be broken. No, this is one. This is 111, and this is 101, or 110.
110.
Hmm?
101.
110.
This is 110. Yes, this is 110, and I think this should be shifted down a little bit in order to have just go horizontal and check. But this is 110, and this one was
101.
101, and this 100, right?
Yes.
Okay. طيب. Okay. So if this is 111, now this link should be broken. لأنه machine number 2 is 1 and then switched off 0, and this one also should be broken. This also should be broken. ليه؟ لأنه again the same constraints. Machine number 2 is on here and it is off here. Okay, so it violates the minimum limit. So these two combination are broken. طيب, for this one, if you investigate the 3 links, so this one, and this one. So this one is 110. So if you go 110, خلاص, everything is okay. You keep it on here. Here you switch it off. Here you switch it off, which is unfeasible. يعني حتى the 2 links دول are unfeasible. Am I right? So
Yes.
we will
Yes.
exclude
Yes.
them.
Yes.
We will exclude them according to, again, the same constraints. Let us investigate this one. This is this combination is 101, and if you go to 110, there is no problem. You switch it on here, no problem. And if you have 101 to 101, there is no problem. Okay, and from 101 to 101, this is okay, no problem. لأنك أنت you keep it off here for 2 hours. It is, يعني no problem. So there is no violation of the constraints. So based on this constraints of minimum startup time for machine number 2, we eliminate 1, 2, 3, 4 combination again. So you have now, we end up with how many combination?
6.
1, 2, 3, 4, 6. 6 combination. You can have this combination here and this, or this one, this one, this one. You can see the path is remaining. The remaining path is here. So this could be a solution. This is a feasible solution. And this one is a feasible solution. This one is a feasible solution. This one is another feasible solution. This one is another feasible solution. So you need to investigate. خلاص, now all the constraints are satisfied. All constraints have been satisfied now. We examine the load generation balance, and we eliminate 96% of these combinations, of possible combination, which is 512. And on this shutdown time of unit A, so we eliminate 9, and here we eliminate also like 4 solutions here. So the remaining path is that we need to investigate the cost is as you can see here in red color. Do you have any question on that side?
Yes, doctor. Aren't they 5 combination?
5 combination, yes. Why we say 6? It's 5 combination. 5 combination, yani 5 solutions here. You have 5. This is 1. This is 2. 1, 2, 3, 4, 5. So you have 5 combinations here. not 6 combination, you have 5 combination, 5 feasible combination. Okay.
Clear.
So this is 1, 0, 0. So the solution now, you can imagine the solution in general. Doesn't necessarily to be the minimum, but one of the solutions you can say no 1, 0, 0. This is for the first period, second period, third period, 1, 0, 0, and 1, 1, 1, and 1, 1, 0. This is the one of the solution. Second solution could be 1, 0, 0, and you go to 1, 1, 0, and then you go to 1, 1, 0 again. Solution number 2. Third solution is 1, 0, 0, 1, 0, 1. And from 1, 0, 1, you can go either this way to 1, 1, 0, or you go to this way 1, 0, 1, or you go this way 1, 0, 0. Okay, so you have possible solutions for this. Our next task is to find which one gives you the minimum cost. Which of those solutions gives you the minimum cost? Which of those methods gives you the minimum cost? Keep in your mind the on units, also the startup cost you have to take into consideration while you are calculating the cost. And for example, if you move from this 0 to this one, you will start up machine number 2 or unit B, and then you have to add here for this link, you have to add the startup cost of unit number B. And this one also will be switched on. And to move from this to this, you have a startup for machine number B and machine number C. So you have to add the startup costs together here. Okay. If you, for example, from this one, you have unit B is on only, you will start on unit B, so you have the cost of unit B only to move from this to this one. If you move from this one to this one, you have also the start up cost of unit B, and so on. So in addition to, of course, the operating cost, if you have the operating cost here, machine number 1 only or machine number A is only on, and then the load will be all will be covered by machine number 1, so you can calculate the cost. You have the incremental cost lambda, and then you can you can calculate the cost at this operating pattern, and you can calculate the cost at this operating pattern. And you calculate the operating cost. This is the fuel cost, and we have different type of costs. We have fuel cost, and this comes from the cost function. And we have a startup cost, and this comes from the moving from one combination to another. You have to check. And for example, in this combination, if we move from this one to this one, machine number 1 is still on, but there is no cost involved here for machine number 1, and that's on. Now machine number B will start it on here. We will change the status from 0 to 1. So we have the startup cost of unit B must be considered here. So out of these combinations, we need to find out which one gives you the minimum cost. So let us start step by step calculating the operating cost, the startup cost. If you have any question before moving to calculating the cost. Any question? Okay, great. طيب خلاص, these are the remaining feasible solutions. And now let us calculate the cost accordingly. Okay, so for status 1, how much the cost? I just remind you, but by the unit, minimum, maximum, and no load cost, and the marginal cost, and also startup cost later on will be taken into consideration. So if you have the status one, this is 100. Okay, the load here is 150. The load is 150, and you have only machine number A is on. So this machine, or the power output of this machine, will be 150, and this is 0, and this is 0. Is it clear? Am I right?
Yes. Yes.
Yes.
Yes.
Okay.
Yes.
For example, for this one, how much the cost? If this is the case, how much the operating cost? The operating cost. The operating cost, let us say this is 150 megawatt, and the unit given here is unit A is on, and the marginal cost is $10 per megawatt hour. So the operating cost will be, operating cost for this combination will be 150 times 10 times the marginal cost. And I would like to ask you, if we have such case, the no load cost is 0, the marginal cost is 10. Can you construct the cost function for this? Cost function for A. Can you construct it as an equation?
It is 10 times B.
Exactly 10 times B. That's all. There is no load cost. Okay. And of course, it is not quadratic. It gives you the marginal cost is constant, معناها linear, and the marginal cost is a derivative. But this is linear, and there is no load cost. يعني حتى the absolute term here is 0. No load cost is 0. So this is 0 plus 10B. And the cost of unit B is 12 BB. And the cost of unit C is 20 BC. Okay. Let me ask you, based on your engineering sense, what do you think the unit C type? What is the type of unit C? What do you expect? Just expectation or guessing.
Gas.
You are right. It is a gas power plant. The power output is limited. The unit is just 50 megawatt. إنما لو بنتكلم عن steam power plants, in this case you have hundreds of megawatts output, but this is only 50. And look at the cost. Look at the cost also. The cost here is $20 per megawatt hour. طبعا الجاز is more expensive than the oil, right? So we expect this to be, this is just an aside information. We expect this to be a gas power plant. So these are the costs or cost function. So for each combination, you can get how much the total cost that you have here. You have here a load is 150, and only the machine number 1 is on. So this status is 1 0, 0. So you have only machine A and the machine B output 0, and machine C the output 0. So the cost is $1,500 per list. The status 2, what is the status 2? This status is 1, 0, 1, 0, 1, right? This status is 1, 0, 1.
Yes.
Am I right? Is it clear?
Yes,
Yes.
please.
So this one is 101. 101 معناها and we have two machines are on, which is 1 and 3. And 1 and 3. The load here is 300 megawatt. So how to distribute this load? طبعا of course machine number A is $10 per megawatt hour. So you will of course make the maximum power output of that machine. Okay. The maximum of that machine is 250. And in machine number 3, so the remaining 50 will be in machine number 3. So 250 and 50 are the output powers to cover the load, which is 300. So the load pattern now is 250, 0, this is off, aslan, and this is 50. So this will be multiplied by $10, and this will be multiplied by $20 marginal cost. So 20 times 50, it becomes 1,000, and this is 2,500, 1,000, $3,500 per hour. So this is the operating cost or fuel cost according to this status or this state. Any question?
Hi,
Yes, please.
the marginal cost is the same as the beta.
The marginal cost, the same as?
Beta in the equation.
Yeah, yes, you are right. And your cost is alpha plus beta B plus gamma B square. Right?
Yes.
When you have your marginal cost, fixed marginal cost here fixed, doesn't depend on power. So this, okay, this term is, is diminished 0. And in this case, lambda equal to beta. The incremental cost, lambda in this case, equal to beta. حتى even there is no load cost. And no load cost is 0, for alpha equal to 0. And you have only a cost function equal to beta p, and the incremental cost equal to beta s. So this is the case now. Is it clear?
Yes.
طيب عباس سعيد, you have a question, Abbas?
Yes, and the same thing, Doctor. If we have a node like in the midterm exam, how do we distribute the load among the generator?
Okay, in this case you have C equal to alpha plus beta. Beta will be also lambda. يعني حتى لو في alpha, it doesn't matter for the incremental cost. Incremental cost, right? اللي هو derivative, alpha will diminish. So beta p. So this is the cost of unit A or unit 1. خليها for simplicity. And for C2, alpha 2 plus beta 2, B2, and so on for others. So in this case, you can see, you can identify which machine gives you the minimum cost, and you load it first. Okay.
So filling the cheaper machine first,
Cheaper
and then set the other two minimum.
Exactly. Yes. If they are on, of course. If they are on. Okay. If they are on. And here this one is off. So we are not caring about its cost. We now comparing 1 and 3. Which one would be loaded first up to its maximum, and then we can examine machine number 3 later, whether it will satisfy the minimum power or you have to reduce from this one and keep this at the minimum level. You have to adjust this, okay? And if you have here no load cost, you can easily adjust. Is it clear, Abbas?
Clear, yes, doctor.
Okay. So let us move forward to status number 3. I think now it becomes easy. This is 110 status. So if you go to 110, 110, so you are distributing the load among machine number 1 and machine number 2. So load is 300, and you have this one should be loaded to the maximum, and the other will be 50, and the minimum is 50. That's okay, and it satisfies the minimum. So the minimum, the cost here, you multiply this by 10 lambda, so 2,500, and you multiply this by 12, so it is 600, 12, 2,500. So the cost, operating cost, is $3,100. خلي بالكم ده الاوبريتنج كوست. احنا لسه ما اتكلمناش عن الستارت اب كوست، لانه this combination, if we move from 100 to 110, we have start up cost. This will be considered later. احنا for this combinations, for all these states, we need to find the fuel cost or operating cost. Okay, this is the operating cost we are calculating. For state number 4, okay, let us go to state number 4. State number 4 is 111. All are on. So for this state 111, and you have 300 load, you have to load this first. So this is the minimum cost. So you will put it 200 at the beginning. And at the beginning you will say, I will consider this 250, and I will distribute the others. And the second one will be also loaded first. So this is 250 and 150, 50. Okay, and 0. This is the case. Okay, for lower cost, isn't it? مظبوط ولا مش مظبوط؟
Yes.
But this of course violates the limit here. لأنه الماشين number 3, this is B1 or BA, and this is BB, and this is BC. You can say machine A is the lowest cost, so I will take the maximum out of it. And then I will load this one with the remaining, and I load this one with the remaining. This one is 50, and this one is 0. But this is not that combination. The combination here is 111. This machine is switched on here. For this combination, it is on. So you have to run it on at least at the minimum power output. You cannot put it at 0. But this is not that combination. But you are talking about this combination, not that combination. If it is on, you have to load it. Okay? You cannot say no, the power is 0. No, the minimum power should be 10. The minimum power should be 10. So you will again adjust this again to this will be 10. But this 10 generated here will be extracted from where? From machine number B or machine number A?
Machine number A.
Why?
Because we are running
Because
B
B
at
is at the
minimum.
minimum.
B at the minimum. Again, if you take it 10 from here, يعني اللوجيك يقول ان احنا okay, we will keep this at the minimum 10, and we will take 10 from here. But if you take 10 from here, this also will violate the limit. You cannot take any power from here. So this would be 50. So again, you will have here 240. You will take it from machine number A. So this is the distribution of the power according to this state. So you have here 240, you have 50, and you have 10. Again, and I would like to emphasize on this. For this state, all the machines are on. You have to satisfy the minimum requirement, and you have also to keep the power output less than the maximum. You cannot say in machine number C is more expensive, so the power output will be 0. No, this is not the combination. This is not that combination. This is that combination. Okay? If it is on, you have to load it at least with the minimum power. For state 5, 6, 7, can you easily do it? Okay, and we don't need to go extensively here for this. Let us take last one, which is this 110. Load is 200 in this case. In this period, load is 200. Let us see status 7, which is 110. So load is 200. So machine number A and machine number B are on, so you have to load them. And we will go at the beginning to load this one with 200, and we will keep this at 0. Load here is 200. So let us take BA equal to 200 and BB is 0. Is it okay or violates the limits of minimum and the maximum? It violates the limits here, right? But this is not the the appropriate distribution of the power output. So we will keep this at the minimum, and we will take 50 megawatt from this one. So this will be 150. So the distribution is 150 and the 50, and this machine is off. It is 0. So you multiply this by 10, and this multiplied by 12. So it is $2,100 cost for this status. Do you have any question for this cost, fuel cost estimation? This is fuel cost estimation. Now we will, next step is to implement the startup cost. يعني احنا بدأنا البروبلم example at the beginning to eliminate the unfeasible solution according to the load generation constraints. This is one. Second, we eliminate the unfeasible solution according to startup time, minimum startup time. We eliminate the unfeasible solution according to shutdown time for all units, A, B, C. And we end up with some of the possible combinations, and then we are starting calculating the cost. The first, the fuel cost is calculated as such. So for each combination now, you can, at this one, you know the operating cost of this one now. Machine unit 1 is $1,500, $3,500. So you can say here this is 1,500, and this one is $3,500, and this one again. And you can put these calculations on each state. So this gives you the full cost. So, okay, so this is the case now. For each state, you have the fuel cost. طيب, this is the operating cost. What about the startup cost? Where did we switch on a unit? And if we switch on a unit, then we have to consider the startup cost. Startup cost given here for the unit number 1. If you started on. So this is 1,000, unit A, unit B, unit C. So this is the startup cost here. So this is the startup cost, okay, for unit type. Now, let us see. This one is 100. This one is 111. And this one is what?
110.
10. Right, okay. Let us take this path and see the startup cost involved in this one. For this link, for this path, what did you do here? You switch on. طبعا احنا هنا الستارت اب كوست خلينا نكتبها هنا عشان just to remind you startup cost. For A it is 1,000. For B it is $600. For C it is 100. طيب, what about the startup cost for this link?
700.
700. Yes, why? And the B you switch it on, and the C also is switched on. This is the previous state 100, and this is 111. So you start up this and you start up this unit here. So we have here $700 startup cost for this link. So when you want to evaluate this path and to get the minimum cost or the total cost of this path, you have to consider here $700 as a startup cost. For this one, what do you think? For this path or this link?
Zero.
This is 111 and this is 110. So how much the cost involved here?
600.
Did we switch on?
Zero.
Did we start up a new a new plant?
No.
يبقى $0. يعني here one is stay on, B also is stay on, and we switch off this one, which is not a problem. This is not starting up. This is shutdown. Shutdown assumes shutdown cost is 0. So in this case, you have 0 cost here. Okay. So if you want to calculate the total cost associated with this path, with this solution, so you can say an operating cost here is 1,500, and we have a startup cost here is 700 plus 1,500 plus 700, and we have operating cost here is 3,200 plus, and you have operating cost here is 0 cost here starting up plus $2,100 here. So if you want to calculate the total cost, so this would be for this path, for this link, for this solution, the total cost is 1,500 operating plus 700 startup plus 3,200 operating plus 0 startup plus 2,100 operating cost. So this will be like 15, 22, 54, and $73.00. So this is the associated cost for that path. Okay? Is it clear?
Yes.
It's clear.
Do you have any question? And this will be repeated for other paths. Okay, let us go to this path. Is there any, this one, this status is 110. Is there any startup involved here? From
Yes.
100 to B. So how much cost here?
$600.
$600 for this link. Up here.
0.
Sure. Okay. So you can say, this is 1,500. Okay. Plus 600 plus 3,100 plus 0 plus 2,100. So this gives you how much?
7,300.
7,300.
Again, same?
I think the previous should be 7,500.
Which one? Did we, okay, we have here 15 plus 7, 22, 54. Yes, this 7,500. Yeah, this is 7,500, and this is 7,300. Okay? Is it clear?
Yes.
Okay.
Yes.
Type. Okay, so okay, we finished this. Is there any, this status is 101. The status here is 101. Is there any startup here?
Yes.
From
Yes.
100
Yes,
to
100.
101?
100.
100. Machine number 3 will be switched on, so we have here $100. And okay, from 2 to 7, from 101 to 110. So how
600.
many? How much?
600.
600. Why? And here we have unit B is off, and we switch it on here. So we start up unit number B, and this will be $600 cost of this link. For this one, definitely it is the same. We didn't do anything, so this is $0 for startup. Nothing started up. And for this one, again, you have how many cost? Do we have any cost involved here? This is
No.
101 to 100. So this is zero cost, zero startup cost. Nothing is started up. Is it clear? So you can say, for the third one, for the third solution, you have this path. This is the path of the third solution. Okay, so you can have 1,500 plus 100, yes. Are you following? Plus 3,500 plus 600 plus 2,100. So how much is this one? This is 16, 51, 57.
7,800.
7,800. Okay. So this is the cost of this bath, of this solution. Type for that one, you have up to here, it's okay. Instead of 600, you will put 0 and 2,100. So you have the other one, you can calculate it. 1,500 plus 100 plus 3,500 plus 0 cost here plus 2,100. So how much this one?
7,200.
7,200. Oh, yeah, this one is much better than the others. طيب, let us check the last one, last bath, which is this one. This bath is, you have it here, 1,500 plus 100 plus 3,500 plus 0 plus 2,000. So how much is this bath?
7,100.
$7,100. So that means, this bath gives you the minimum cost out of the others. Here you can have this one, $7,100. So this is the solution of the LEC commitment problem. This is the status solution. Best solution is as follows: period 1, period 2, and period 3. For period 1, you have 100. right?
Right.
For period 2, you have this one, 101. And for period 3, this gives you the best one, which is 100. And definitely for each period, you have how much BA, how much BB, how much BC. So you can, of course, get this from that table that we construct together. And here for 103 and so on. So this table gives you the solution of BA, BB, BC as we have it here, 250, 50, 240, and so on. So this is the solution of the unit commitment problem. The status and the power output of each generator. So we completely now solved that example. Oh, time is over. And I thought that we will start the security. طيب, time is over, so we will stop here. I think this is the last. Of course, this is the again startup cost. Now we just have all this, and this gives you the lowest cost as we mentioned, and this is the best solution as we discussed. And some notes you have to illustrate the principle, and then these notes are you can go over it quickly. But you can imagine if you have more than 20 units or 100 units in real life systems, you can see how much complexity of the problem is. And by this we end the unit commitment. We will start inshallah in power system security next class. By this we end the unit commitment problem, and we will stop recording now.